Right now, at least 4 coronal mass ejections are heading toward Earth, fired from the same sunspot over 2 days. NOAA has a G2 watch posted through March 20th, and there's a timing factor that could push this storm higher than the models predict, one that has space weather forecasters watching their screens very closely tonight. On March 16th, active region AR4392 erupted with an M2.8 flare peaking at 12:15 UTC. LASCO C2 coronagraph imagery confirmed a full halo CME launched into interplanetary space, moving at roughly 1 million miles per hour. The flare triggered an R1 radio blackout across the Atlantic, northern Africa, and southern Europe. But that was just the opening salvo. Within the next 36 hours, AR4392 fired again and again. A filament eruption at 0300 UTC on March 17 produced a second CME, captured clearly in SOHO coronagraph data. NOAA now confirms at least 4 separate plasma clouds are in transit, with arrival estimates beginning late March 19 through March 20. And here's the factor that could change everything. The spring equinox arrives on March 21st. Let's talk about what we're actually dealing with. A coronal mass ejection is a cloud of magnetized solar plasma, typically billions of tons of charged particles, carrying its own embedded magnetic field. When that cloud reaches Earth, what matters most isn't its speed or its density, it's the orientation of its magnetic field, specifically the north-south component we call BZ. When BZ swings southward, the CME's magnetic field connects directly to Earth's magnetosphere. The shield opens. Solar wind pours in along field lines toward the poles, energizing oxygen and nitrogen atoms in the upper atmosphere. That's the Aurora. When BZ stays northward, even a massive CME can slide past with minimal impact. That's why space weather forecasting is so uncertain until the plasma actually reaches the DSCOVR and ACE monitoring satellites at the L1 point, roughly 1 million miles sunward. Only then do we get real-time BZ readings. Right now, models suggest the first CME will arrive late on March 19 Eastern Time. Solar wind speeds ahead of the event have been declining from around 550 kilometers per second down to roughly 450 as the earlier coronal hole influence fades. The current KP index sits at 1. That will change. NOAA's forecast calls for active conditions pushing G1 to G2 on March 19th, with possible G3 if the BZ component cooperates. The second CME, from the March 17 filament eruption, is modeled to deliver a glancing blow around March 21, but its proximity to the first arrival could amplify the combined geomagnetic response. Stacked CME arrivals can compress the magnetosphere in ways that individual events don't. Now, the equinox factor. This is the Russell-McPherron effect, and it's one of the most important seasonal patterns in space weather. In 1973, geophysicists Christopher Russell and Robert McPherron published a landmark paper showing that geomagnetic storms are statistically stronger around the spring and autumn equinoxes. The reason is geometric. Earth's magnetic dipole is tilted roughly 11 degrees from its rotational axis. For most of the year, this tilt creates an angle between the solar wind's magnetic field and Earth's field that reduces coupling efficiency. Think of it as a partial deflection. Around the equinoxes, Earth's orientation in space aligns so that the solar wind can connect more effectively with the magnetosphere. The coupling efficiency increases. The same CME that would produce a G1 storm in July could produce a G2 or G3 in March. This isn't speculation, it's a well-documented statistical pattern across decades of geomagnetic data. The equinox is tomorrow, 4 CMEs are arriving. That overlap is what has forecasters paying close attention. Let's look at what the OVATION Aurora model is showing. As of the latest run, the auroral oval is expected to expand significantly during peak storm conditions. If we reach sustained G2 with KP6, the primary viewing zone extends across the northern United States, Alaska, Washington, Oregon, Montana, Idaho, Wyoming, the Dakotas, Nebraska, Minnesota, Iowa, Wisconsin, Michigan, Vermont, New Hampshire, and Maine. If conditions push to G3 with KP7, the oval expands further south. Northern Illinois, northern Indiana, northern Ohio, and parts of Pennsylvania enter the zone. Peak activity is forecast between 0200 and 0800 UTC on March 25th, which translates to roughly 10 p.m. Eastern on March 19 through 4 a.m. Eastern on March 20. But with multiple CME arrivals expected over a multi-day window, the storm could come in waves. You might see a burst of activity, then a quiet period, then another surge as the trailing CME arrives or as BZ rotates southward again. Your viewing strategy for tonight: get away from light pollution, find a location with a clear, unobstructed view of the northern horizon, ideally below Bortle Class 5 skies if possible. Give your eyes at least 15 to 20 minutes to fully dark adapt. Use a camera with manual settings because phones in night mode can often pick up aurora that the naked eye struggles with at mid-latitudes. Green is the most common color at lower latitudes, but if conditions strengthen, you could see purples and reds at higher elevations in the atmosphere. Monitor real-time data during the event. The NOAA SWPC dashboard gives you current KP readings, BZ values from DSCOVR, and solar wind speed. Space Weather Live provides excellent real-time visualization. When you see BZ drop below -10 nanotela and solar wind speeds jump, conditions are active. That's your signal to step outside. AR4392 is still active and evolving, carrying a beta-gamma magnetic configuration that indicates stored magnetic energy capable of producing additional eruptions. NOAA gives a 35% probability of further M-class flares today, with a 5% chance of X-class activity. If another strong eruption produces an Earth-directed CME in the next 24 hours, we could see extended and intensified storm conditions well beyond the current forecast window. The sun is not done. Solar maximum isn't done with us yet. Activity across the disk is expected to remain elevated through the second half of 2026, meaning more events like this one are coming. One important note of caution. Space weather predictions carry significant uncertainty until the plasma is measured directly at L1. Models can estimate arrival time, but the actual BZ orientation, which determines storm intensity, is essentially unknown until the CME reaches the monitoring satellites about 30 to 60 minutes before it reaches Earth. Storms that look promising on paper can fizzle if BZ stays north. Storms that look moderate can explode if BZ swings hard south. That's the nature of this science. We watch, we wait, and we respond to what the data shows us in real time. Tonight has real potential. 4 CMEs, equinox geometry, an active sunspot that isn't finished yet. Whether this becomes a memorable aurora night or a near miss depends on what happens when that plasma reaches L1. Keep your alerts on, keep your cameras ready, and if you catch the aurora tonight, share your photos and location with us. The space weather community makes these events better. Where are you watching from, and what's your prediction? G2, G3, or a surprise G4? The sun has spoken clearly. Now we wait for the answer.